Alright, welcome to Informal Geometry. This is chapter 13, section 1. We are dealing with circles and chords. So this whole chapter is dealing with circles, and we're going to go into some basic definitions of different parts of a circle as we go through. So first off is some quick definitions for you. A circle is basically it's a locus of points on a plane or in a plane that is a given distance from a single point. So if you're on a piece of paper and you put a point in the middle of the paper, what are all the points that are 3 inches from that single point in the middle of the paper? And if you do that, you'll notice you'll always get a circle. Okay, and so that is what a circle is it's points. It's all the points that are a given distance from a single point. And that's what a circle is. So the center of it is the point that's in the middle of a circle. So if you have a circle and then you have that middle point, and that is your center, okay? Usually denoted as C for center, okay? So that's what the center is. So the center is that middle point of it. The radius is the segment whose endpoints are the center of the circle and somewhere on the circle. So the radius will have the center, will be at the center and on the circle somewhere. So it's the length from the center of the circle to one side of it. And a chord is where you have both endpoints on the circle somewhere. And the last one is a diameter, which a diameter is a chord that contains the center of the circle. So it's a chord that's drawn within the circle that also has the center of the circle within that line. Okay, so the diameter is a chord. So let's say we have this circle. Okay, so let's say we have a circle, and then we have this middle point right here. This middle point I'm denoting as C. That is your center. Okay, now if that's our center, okay, in orange now, if I go from the center to one point on the line, that is a radius. Okay, that is a radius. Okay, same thing with this one, and same thing with this one. Those are all radii. Okay, so all those orange ones would be considered radius. They're going from the center of the circle to some point on the circle. Okay, the next thing we have is a chord. Now, a chord I'm going to do here in green. Okay, so all of these would be considered chords. Okay. Okay. So all of those are chords. And as you see, they have one point on the circle and their second point also on the circle. Okay. They could be larger, they could go through a longer point. Okay. And the last thing we have is our diameter. Okay, which our diameter is a line that ends up going through the center of the circle. Okay, ends up going through the center of the circle and has endpoints on the circle. So this is our diameter. Okay, so that purple line is our diameter. And a circle has an infinite number of diameters. You can keep drawing an infinite number of chords, an infinite number of radii that you can draw all the way around. So those are the key parts of a circle that we are looking at. Okay, so now, first theorem that we have is that all radii in a given circle are congruent. So if one radii is 10, all of them are 10. If one is 6, they're all 6. If one is a half, they're all 1/2. Okay, so the radii cannot change once you know what it is. Okay. Second one is that the diameter of a circle is always twice the radius, or the equation d equals 2r. So the diameter will always be twice the radius, or if you want to think of it the other way, the radius is always half the diameter. So the other equation you could have is that r is equal to d over 2. Okay, so that would be the other way you could do it. So the radius is always half the diameter, or the diameter is always twice the radius. Okay. So let's say I have a circle, and here's my center, and I draw a radius of 3. Okay, so the question here would be, let's do it in different colors. Let's do it in green. So this green line and this green line. So the first green line, the shorter of the green lines, that length would have to be 3 because it has to be the exact same length as the other radius because it is a radius. All radii are the same. And then the other line, the one that's going through, has to be 6 because it's 2 radii together, which would make it 6. Now, if I drew another chord, let's say right here, okay, we don't have enough information to be able to find what that length is. So that length, we have no idea what it is. Random chords inside circles have no real relationship with the radii and diameter. Okay, there are some things that you can do with if it's perpendicular and different things like that, but just a random chord drawn inside of a circle, there's no relationship between that chord and a diameter or a radius. Okay, except that it has to be less than the length of the diameter, because the diameter is also the longest distance from point to point in a circle. Okay. All right, so here's your homework for this section. That you have 439 numbers 1 through 19. Make sure you get on it. It's starting our intro into circles.